Now let's look at the problem 55. We graph this cotangent of x over 2. 55, y equal to cotangent of x over 2. So first, let's get the period. Period P is equal to pi divided by the coefficient of x, that is 1/2. So we get 2 pi. And let's get the one cycle of this function. So the fundamental cycle of cotangent of x is between the 0 and pi. So we multiply both sides by 2, then we get x is greater than 0 and less than 2 pi. We know x at 0 and x at 2 pi, this function has the vertical asymptotes. So let's first draw the two vertical asymptotes. So at x equals 0, we have the vertical asymptote, and at x equal to 2 pi, we have another vertical asymptote. Then the graph of this y equal to cotangent of 2x is like this. You know, it's a decreasing function. Okay, so this is a graph of the y equal to cotangent of x over 2. Now let's look at the problem 59. Get the period of this y equal to -2 times tangent x, and then sketch for one cycle. So 59, we have the y equal to -2 times tangent of x, and since the coefficient of x is equal to 1, so the period is just equal to pi. That is period of the tangent x. And let's first get the graph of the y equal to tangent x. So let's draw the graph of y equal to tangent x. And let's first get the two vertical asymptotes. So this is the -half pi, and this is half pi. And we know the graph of the y equal to tangent x is like this. Okay, and this is the graph of y equal to tangent x. Then let's get the graph of y equal to 2 times tangent x. So actually you just stretch the graph of the y equal to tangent x by a factor of 2, and then you get the graph of y equal to 2 times tangent x. So the graph of this y equal to 2 times tangent x is like this. Okay, and to get the graph of this y equal to -2 times tangent x, we may just reflect the graph of y equal to 2 times tangent x about this x-axis. So you reflect this red graph about this x-axis, then you get the graph like this. This blue one is the graph of y equal to negative 2 times tangent x. Now let's look at the problem 78. Determine the period and sketch at least one cycle of the graph of this y equal to cosecant of 3x plus pi, and state the range of this function. So problem 78, function is y equal to cosecant of 3x plus pi. And let's first get the period. We know the period of the cosecant function is equal to 2 pi. So the period of this cosecant of 3x plus pi is equal to 2 pi divided by the coefficient of the x, that is 3. So the period is equal to 2 pi over 3. And to graph this function for one cycle, let's first begin with the graph of the y equal to sine of 3x. And we know this function completes its fundamental cycle for 3x between the negative half pi and half pi, and we divide each part by 3, then we get negative pi over 6. So actually less than or equal to, then we get x greater than or equal to negative pi over 6, and less than or equal to pi over 6. So first we may get the graph of this function for this fundamental cycle. We know sine of x completes its fundamental cycle for x between the 0 and 2 pi. So the y equal to sine of 3x completes its fundamental cycle for 3x between the 0 and 2 pi. Now we divide each part by 3, then we get x is greater than or equal to 0 and less than or equal to 2 pi over 3. Now the next step, we need to get the graph of the y equal to sine of the 3x plus pi, and we can rewrite this as sine of 3 times x minus negative pi over 3. So let's first get the graph of the y equal to sine of 3x. So this is the 2 pi over 3, and this is pi over 3. Now to get the graph of y equal to sine of 3x plus pi, we need to shift the graph of this y equal to sine of 3x to the left by pi over 3. So pi over 3, so that means this point shifted to this point, and this point shifted to this point, and then we get the graph like this. And this point shifted to this point, and this point shifted here. Okay, so this red one is graph of y equal to sine of 3x plus pi.